Hello everyone, I am Sai Kumar Reddy Palnati, MSc in Cloud Computing, and today I will be presenting my project on edge powered smart home energy management optimizing IoT task scheduling with 5G. And this work is focused on reducing latency in IoT task scheduling with 5G connectivity. And the goal is to implement task scheduling for smart home IoT devices using edge nodes to reduce latency. And this work is inspired by Shen et 2021, which applied deep reinforcement learning to IoT based edge computing. And in cloud only IoT. And the problem is like in cloud only IoT devices, like high latency is a major challenge for time sensitive tasks. Uh, and the solution uh, is by introducing edge computing with 5G, we can process tasks to the devices and achieve near real-time performance. And the tools we are using are iFox Simulation 2 and Java and VS Code for IDE. And the goal is to optimize energy usage in smart homes by scheduling IoT tasks to edge nodes or cloud. And the components we are using are IoT layer, where, for example, 10 sensors were uh, monitored by using power usage and temperature. And in edge layer, we are using 5 nodes for fast and for local, and then remaining for the processing. And in cloud layer, it's a heavy processing layer. Uh, and the question is like, why only edge computing? Because it reduces latency and minimizes cloud data volume. And this is a system architecture. Basically, we have three layers: IoT devices, edge nodes, and cloud server. And in implementation part, uh, we are using uh, Java for by using iFox Sim2 for simulation, and we are going to process 10 sensors, one edge node and one cloud server. Edge nodes will be processed. The task will be processed in edge nodes for high priority tasks, and cloud will handle others. And these were the results for both edge scenario and cloud based scenarios. And let me show you the implementation part. Yep. And uh, here we have the uh, fog simulation requirements, and then this is for the cloud server, and this for the edge server, and this is for the sensors, and this is for the simulation part. And when we run this, yep, and when we run those, then these are the results for edge processing scenario, where in total 10 tasks successful were 4 and offloaded to the cloud were 6, and average latency was 2.24 and data retention were only 40%. And in cloud based scenario, the total tasks were 10, successful tasks were 10, and offload to cloud were 10, and average latency was only 13 milliseconds and data reaction is 0. And this is a latency charts for both edge and cloud. And also the simulation results were stored in a CSV file, where for the 10 scenarios, 10 sensors, for every sensor, like what the timestamp and what is the power usage and where it's processed in cloud or else in edge. And yeah, and in conclusion part, and we achieved a valid reduced latency using edge computing, and we have implemented IoT edge cloud systems for the simulation and demonstrated big data processing at edge. And in future work, we have to implement machine learning algorithms uh, to process the work. And yeah, thank you.